So today we're going to be trying to design this USB charging module for lithium polymer batteries. So we use a lot of these for ESP32 projects, so we're going to be kind of designing this and making a couple modifications to make it 3.3 volt compatible. What's really fun about these is they are crazy cheap on Amazon. So if we kind of look through here, I think I found one where you could like order like 50 of them for like $15. So here's like 20 for 10. So they're actually very, very cheap to buy online. So the question would be is like, why would we want to design our own? And the answer is to be able to integrate them onto just other PCB projects without having to kind of solder a board on top of a board. So that would hopefully give me a little bit more flexibility in terms of kind of where the components are, and also sometimes we'll want the USB connector to charge it and sometimes not for like solar powered projects. So it's just to give it a little bit more flexibility. It will ironically end up costing more than just these modules, but that's okay. We're just going to kind of go with what we've got. So I'd never built something like this before, but I did find a schematic for it that we're going to be trying to follow the best that we possibly can. And also just kind of looking at this and yeah, kind of doing our darndest to figure out how to make this work. So I'm actually going to pull up an image of this so that we can kind of look at this board as closely as possible. I also have these in the lab, but so this will help kind of make sure that we're staying on the right track here. Okay, so let's get started. First thing is we're going to go do some part shopping. So I've got LCSC opened up here, and we're going to go shopping for these big components first. So the TP4056, that's the really big one. So TP4056, that's the actual battery management module. And so it looks like we've got several to choose from. Always going to make sure that we're looking for the ones that are in stock. We'll sort by price, but these should all be pretty inexpensive. Okay. And then what I'm going to do is I'm going to take this part number. And other thing that I like to do is, so we're going to call this LiPo charging module. And we're going to drop this in here and search for it. And I want to make sure that this has a 3D printed, or sorry, a 3D model in here. So I'm going to place this here. I'm going to save. It does that. We'll go over to design. We'll convert schematic to PCB. Just because I like to have the 3D models, especially if I'm going to be doing some enclosures and stuff. And so, sure, we'll just drag that guy there, save, and then we'll just do a 3D render here. Okay, cool. Yeah, so we can see that it does have the 3D model there. So that's really cool. I like that. I also absolutely hate that board outline, so we're going to get rid of that. I'm going to definitely change this board outline later on, but for now, I can change that up from millimeters, grid size to 10, snap size to 10. So you're going to make a big old grid that will change later on, but this will let me kind of test all my components to make sure I've got 3D models for them. All right, so there is temp. I wonder if it has a temperature sensor on it. All right, so next is this DW01A. So let's have a look to see if we've got that. So DW01A. Looks like those are available. And again, looking for things that have lots in stock. I have built stuff with components that go out of stock really quickly, and those are always very sad. And at the end of the day, not much that difference between 3 cents and 4 cents, dear heavens. In fact, this one is 6 cents, and there's lots in stock. So I'm going to go with this one. So we're going to bring that over here, drop it in. These are all surface mount, which is good. So, again, I'm going to save that up. Oh, I want to exit out of that. I want update PCB. And again, the whole reason for this is just making sure that everything's got a 3D model associated with it. And they should, because they're all kind of standard package sizes. And I kind of see that it's literally just using the package editor. But that's good. Sometimes they don't. All right, next, let's look for this FS825A. FS825A. Not as many options here. So 6 cents, 6 cents, cool. Let's go with the one that has 30,000 in stock. Ooh, now this one may not actually have. Sometimes when they get these really long part numbers, I've noticed that they don't actually have models for them. So let's take a look. Oh, it looks like it's a verified part. Okay, and we're going to place it there. And let's update our PCB. There. And this is probably the last time we're going to have to do this. Okay, cool. When I say that, there's one other thing that we probably want to bring in, and that is the USB connector. So I have one that I like to use. Is it this one? It is not this one, I don't think. 4953. We're going to look this part up. Let's see, 4953. I've had issues with some of these. See, that just doesn't have very big anchors on it, and I've had those rip off. I've got another one that I like to use. I probably use it on my other account, so I'm going to go and look it up real quick because I would like to design something that doesn't fall apart. And so, you know, one of my students put me onto one of these new ones, and I've had good luck with it. So, I go here. The perils of having multiple easy EDA accounts. Sometimes you forget where you stash everything. Let's see. So let's do pop art. This should have the right one on it. Alright, this is probably the one that I'm looking for. Ah, yeah, I see those big metal posts there. That's what I'm looking for. Just so you don't rip stuff off. Okay, so in here. Oops. All right. There we go. All right. PCB, and this is probably the last part that I'll have to check for. A 3D model, and I'm pretty sure it has this one, but better safe than sorry. Ooh, hello. Weird. Definitely is there, although I loaded in all funky, but yep. Okay, so we got 3D models for everything. Yeah, and the rest of these are just jelly bean components, so those should be okay. One thing I may leave off, I guess, is these are some LEDs that are status LEDs. I guess I can put those in there, and you could always take them off if you didn't want them. Okay, so let's kind of get things a little bit organized. So 4056 is there, there, and then over here is the charging stuff. So that's going to come over here. Okie dokie. Alright, so let's go shopping for some LEDs. Just want some LEDs, not drivers. Light emitting diodes, there we go. I don't know why that was so hard. Okay, and I like 0603. I definitely want some that are in stock. And then we get to choose a color. So I think kind of red for charging and green for being charged, maybe? Okay. Lots to choose from there, dear heavens. And 0.6 cents a piece, so that's a pretty big deal, I think. All right, so let's put this one in here. Yay, LED. Okay. And then let's go see if we can find one that is green. Green, yellow, green. Emerald. Okay, let's go with blue. Why so weird? Doesn't seem... Did I just pick a weird color? Or a weird size? Maybe I did pick a weird size. Maybe the 0603 is too small. I like 0603. Okay, well, works for me. Okie dokie. And there's a billion of those. All right. Ooh, okay. All right. So let's throw in a blue LED. Oh, how nice. Red, blue. Very nice. Alrighty. Let's keep looking here. Okay, so 1K resistor for each of those. So let's go to resistors. And again, we're going to do 0603 and 1K. Here, somewhere. In stock, apply. All right. 76,000 in stock, that's fine. Unioil, I've used these guys before. That's a really big part number. Hopefully they have them in the library. Here's what they do. Alright, so those guys are going to go there. Okay, looks like we've got, we'll do R1, R2. Let's go R3 is a 1.2K. So reset. 1.2K. Okay, apply. Okay, I'm going to stick with these Uniroyals just to be consistent. Okay, associates, yeah, with that component, good. Let's go R4, so 1, 2, R3. Am I missing R4? I see R5 and R6. I don't see an R4. If you see an R4, hit it up in the chat. But I don't see an R4 on that. Okay, well, we'll jump to this 100 ohm. And hopefully somebody can let me know if I'm just blind. All right, let's go with 100 ohm. let's do there we go. Okay, and that's going to go with the DW01A. So I'll kind of show you over here where you belong. And then looks like there is a 1K with the DW01A. So we can do this guy and throw you there. Okay. So I'll just have to keep track of my my numbers. Okay. Let's look at some capacitors. So it looks like I've got a 10 microfarad, a 0.1 microfarad, and another 0.1 microfarad. All right, let's go shopping for capacitors. Okay, we're gonna look at some 0603s, maybe. We'll see. This may be ambitious. Yeah, mostly because they don't make them that small. Alright. What is another common type? Size. Let's have a look-see. Really? Jeez. Yeah, those 0805s may be a little bit bigger. Let's try this. Because that's probably what's on there. I'm probably getting a little ambitious with those 0603s, but whatever. Okay, let's try 0805. Maybe that'll give me some more options. Okay, that's looking better. Okay, so I'm looking for a 10 microfarad. There you are. Stuck. Apply. Oh, centerpiece. Okay. Samsung. Sweet. Okay. And that's going to hang out with the DW01A. So alright, and C1, C2 is a 0.1, and that also hangs out there. So let's see if we can find one of those. New, however, you're going to laugh, but 0.1, so 0.1 UF to NF. My micro to nano is a little off. That's not exactly what I'm asking to... Oh, wait, hold on. 0.1 microfarad. That is you silly goose. 0.1. Yeah, if I did that to picofarad, yeah, that's probably... So, yeah... I want to nano. Okay. So, 100 nano. Okay. So it might be... Yeah, so again, not in that size. So let's reset. Let's do 100. Well, actually, yeah, do this one. Okay, so it's not available in that size. 0402. No, I can get that in an 0603. Ooh, let's do that. You lied. You said there's one remaining. Okay. I'm going to roll forward to you. Okay, let's reset that. There we go. It just didn't like the 0.1. Alright, now we're back in business. And look at the total. What would they? Alright. 1590. And I completely lost my train of thought. Where's this going? So that's a 0.1 is going there, and then I got a 0.1 going with the TP. Alright. There, and one going over there. Okie dokie. Alright, I haven't done a lot, so let's go ahead and save up a little bit here. Alright, so. Okay, then we're going to need a couple of points. So we need our ins, our outs, and our Bs. Ooh, look at you. Oh no, I already got you. 1, 2, 3. Looks like that's all the capacitors. Okay. For connectors, we're going to go over to the commonly library, and I like to use these guys, and I need a 1x2, and we'll call these in, out, and that. Right. Okay. And I think we are probably ready to go. Alright, so I'm going to rotate that one a couple times. Gets up nicely. So let's start with some ground connections. Ooh, so I don't want that to be PCC, do I? So we're going to call this DN. Cool. Okay. And that's going to be closely related to this guy, which is going to have a ground connection. And also VN. Cool. So that's going to be kind of the incoming raw voltages. Okay, and let's look at down our little schematic here. So it looks like grounds are always grounds, but yeah, these are not always the same thing. So, so we'll do out plus, out minus, B plus, B minus. Okay. So we got some text over here. And we're going to kind of organize this a little bit. And we'll have our outgoing power. Okay. And so, yeah. A couple of ground connections here. Ooh. out. And we'll call this that. Okay. Cool. Now we got those guys taken care of. All right. Now let's look at this guy. I just want to make sure I'm thinking things through. Okay, so this is the charger. Okay. Now this is going to be a little tricky because I know we're going to have to really look closely at pin assignments because this diagram does not look like our symbol, but hopefully the pin assignments will be the same. We can double check. So we're going to look at pins 6 and 7, and so hopefully if we look at this component, new data sheet, will this actually work? Well, lovely. All right, let's pull the data sheet. So if we look at pin 6 and 7, that should be some sort of status. Oh, goody, goody. Ooh, sure. Charging standby. Yeah, pin 6 and 7, charging standby. Cool, okay. So that's convincing enough for me to move forward that these are probably the same. Okay. So let's just move through this pin by pin. All right. So this looks like pin 1 connects to pin 4 of the FS train. So I'm going to kind of look at pin 1 is temp. Okay. So, oh, indeed it is. Alright, so we're just going to label that guy up. I love net flags, by the way. Remember what my circuits used to look like before I had net flags, and they were terrible. Okay, and this is the... I really like to line my labels up nicely, too. Okay, so... Wait, whoa! Hold on a second. I'm getting ahead of myself. I'm working on the wrong thing. So 4056. Yeah. What? Yeah, okay. So these are just both tied. Pins 1 and 3 are tied to ground. I was looking at the wrong component. So let's not do that. Let's tie pin 1 and 3 to ground. I don't know what I was smoking for a moment there. All right, let's go back. Okay, pin 2 goes to our 1.2K resistor and also goes to ground. Easy peasy. So 1.2 resistor. And also goes to ground. Better. Cool. Notice how I save a lot. Okay. 1, 2, 3. It's good. Okay. Pin 4. Okay, let's have a look-see. Okay, pin 4 and 8 both get tied into the incoming positive, and also we've got that coming close by. Okay, so pin 4 and 8 incoming positive. Okay, so be in there. Okay, and pin 8 be in there. And let's get that capacitor taken care of. That's the 0.1 capacitor, the decoupling. Okay, so that's the 100 nanofarad. And it's going to be in close proximity to this guy. You go away. Cool. All right, moving on. So 1, 2, 3, 4, 5 goes to the out plus. Okay. So that's V out to 5. Okay, 6 goes to our 1K resistor. Good. To the negative side of our LED. And that's going to be the blue one. Cool. Okay, so we're going to do a net flag for this. We'll call this standby. Alright, and then our blue is here. Which will get hooked up to this guy. And this, if I'm not mistaken, gets plugged into VN. Good. So standby comes across here. Perfect. And we're going to do the same. And you'll notice that I always place my pins a little bit farther apart. You can connect them, but it always makes me nervous because I always, are they really connected? I've had some unconnected things. So CHRG for charged. Alright, so it looks like what's going to happen is when it's charging, the red will light up. When it's fully charged and in standby, the blue will light up. Alright, I'm just going to kind of keep part managing these things just to kind of keep things nice and easy. There we go. Okay. Better trading. I think these last ones are for battery protection. Well, let's explore that. Alright, so you're going to definitely go away. I think these are all belonging to this one. And we'll get to this guy in a little bit. Alright, so let's look at that. So that can go away. Alright. Alright. So here, looks like pin 1 goes to pin 4. Now the question is what is pin 1? OD. Cool, it sure is. I don't know what that means. So, overdischarge possibly? If it's a protection circuit. So we're going to call this section over here protection. Okay, so overdischarge 1 goes to pin 4. Is that correct? Pin 1 to pin 4. Cool. Excellent. Okay. Pin 2 is a 1K resistor that goes to pins 6 and 7 and ground. Okay, so 1K to 2. So here's a 1K resistor. A little more room. Ew, gross. Okay. Okay. Oop, lost my train of thought. Okay, so that goes to pin 6 and 7 and ground. And what are you? VM. Voltage monitoring, maybe? So pins 6 and 7. I don't have that many pins here. Let's look at that. So FS825A. Did I grab the wrong part? FS825A. Or maybe it just is a different package. That has. Aha. Yep, I grabbed the wrong package. Oh god, that's a beefy one. Let's look at this. Because maybe it just has some that are not connected, and we could kind of do a simple swap. What's on this one? Oh, that's interesting. So those are both soldered together. So it does use the beefy package. Alright, so beefy package it is. Let's go grab beefy boy. So, yeah. Excuse me, sir. You are not correct. Aha. Alright, so let's go back to OD. So 1 is supposed to hook up to pin 4. So you right there. Okay, so pin 4. Alright, now I really lost my train of thought. Let's have a look-see. So, pin 2, pins 6 and 7. That's right. Okay, so pins 6 and 7 of this VM pin. Cool. And then VM also is supposed to go to ground. Okay. So let's go ahead and just add a ground right there. Ooh, that looks weird. I low-key hate that. Does it do that? think. Okay, let's look at pin 3. Pin 3 goes to pin 5. Okay, so OC, if I had to guess, probably overcurrent. Or overcurrent protection. That goes to pin 5. Sweet. Alright, pin 4, not connected. Okay, pin 5, got a couple things going on. Okay, pin 5 goes to a 100 ohm resistor and a capacitor to pin 6. So, and to B plus. Alright, so let's take this one at a time. So 100 ohm to pin 5. Okay. And that goes to B plus. And just to double check, I'm pretty sure the B plus and minus are all just tied the same place. Yeah, so those are all just tied. I'm just going to go ahead and do that. This is going to look really stupid. I'm okay with it. These are literally the same. Net. Okay. Okay, then I've got a capacitor going to pins 5 and 6. That's my point 1. Okay. And that capacitor also goes to pins 2 and 3 and B minus. Okay, so it probably needs a net flag. Oh, it's ground. Cool. Pins 2 and 3. At that point, it's just all going to ground. So I should just be able to ground all of these, I would think. And that happens 5 to 6, and then off of pin 6 to ground. So off of pin 6 to ground. Which means I can ground pins 2 and 3. I know that looks weird, but that's kind of just my style. Okay. Alright. Let's keep going. So 1, 2, 3, 4, 5, 6. Just double check that 4 is not supposed to be connected. Great. Alright, let's go down to this one. So 1 and 8, not connected. 1 and 8, not connected. Okay. And then at this point, I just need a this is connecting out in V plus just to the out minus. Okay, that's fine. So let's get this guy over here. Actually, we're going to call this power pool. Oh, lovely. You know what? I'm going to make this look not as stupid. I see that. I might do something like that. Cool. Whew. All right. I think that is the whole kit and caboodle. Then I have to actually design a PCB. How are we doing in time? 48 minutes. Oh, that's been fun. Okay. So. Alright, so let's update PCB. There's going to be a lot going on here. Yes, do all those things. Gross. That's what I get for leaving my snaps rise on. Okay, let's just show all this. Make sure we've got 3D components for everything. It was literally the worst board outline ever. Really? I have one LED that's not showing up. Oh my goodness. Everything is the worst. Alright, well, it's fine, I guess. Alright, so I'm going to straight up get rid of that whole board outline because that's just nonsense. Okay. And let's start thinking about just orientation. So that's kind of important. Because again, ultimately all of this is going to kind of end up getting incorporated onto a real PCB, but it'd be kind of nice to have a standalone module just to prove that it worked. Okay, so we're just going to kind of do our thing here. So let's think logically. Just kind of step through. Power coming in, power coming out, and then power from the battery. Let's see how kind of compact we can make all this. Let's see, where are you? You. There. We're just going to start adding kind of support components around it. Okay, so let's have a look-see. So we've got the 2 resistors and the LEDs. Okay. Oops. We'll do labels in a little bit, I guess. Let's see. We got R1 and R2 for those. One thing I'd like to do here is I'd like to turn off ground, leave those on for now, since those are separate. Now the question is going to be is what do we want to have for our power and ground plane? My guess is probably the out plus and the B plus are going to be that. So we'll out plus. It probably didn't even do the B plus because it's just ended up being the same thing, didn't it? But yeah, I don't see it listed here because it is just the identical. Okay, that's cool. All right, next up, this dude. And all of these fun components come hang out. This resistor wants to hang out over here. And this resistor wants to hang out over here. This resistor wants to hang out over here. Oh, interesting. Big cooling pattern right there. That's smart. Everything's cool. Nothing weird going on with this circuit. Trying to balance everything, kind of just finding just the right place. Because of all the different values of resistors and capacitors, I am trying to make sense out of labeling them. Probably the most space efficient thing to do, but when it comes time to put it together, I might be happy that I did this. We'll see. And hopefully I can actually route all this. Alright, I'm going to save that because I've been doing this a long time without saving. But let's see how we did. I think we're in a 20 by 30 millimeter space, so that's kind of cool. Alright. Let's begin the routing on the top layer. It won't let me get it. Ew, gross. What is that? Oh my gosh. Really? You gonna do me like that? Better. was this a good plan? Well, it's not great, but I think it's better. That looks gross. Still kind of gross, but I'll get over it in time. Crazy islands did I create doing that? Probably a lot. That ground's not going to be too happy. But that ground also has to be a through. But I should probably make sure that it actually can go through there. Give it a little bit of a wider berth than that. That didn't actually connect, did it? I really feel like it's going to have issues with that. Probably because it is. Alright, how we doing? Hey, 16 out of 23. Let's keep going. Okay, so you're going to flip around there. Nice, easy peasy. Gross. Some of these tracks are just the worst. Just hate the shape of it. There we go. That's significantly less disgusting. Always gotta be careful about these compounds. I'm looking forward to seeing just the sheer number of islands that I have with this kind of circuit. Alright, so let's go to our board outline and change our snap size to 5. Change my screen tinter. It's always tricky. Disable for now. Hey, now I can actually see colors again. Alright. some islands. Let me back up a little bit. Before I do that, I need to drop some vias for grounds. I like placing vias. Very relaxing. Okay, I'm going to run the ground plane first, just to make sure I've got all the components. Oh no! What are you? Where have you been this whole time? Oh, that's the worst feeling in the world. What do you need? You need ground. Oh my goodness. Why have I done this? I'm going to do something really ugly. You didn't see anything. Oh, that's so ugly. Why would I do this to myself? Alright, well, let's try it. Alright, bottom layer. I'd like to do all of my ground planes on the bottom layer. Let's do this. Okay. Alright. Moment of truth. I don't think it's gonna work. I think I've got some islands, but let's have a look. All right, and this is going to be V out. Yeah, no. So I think if I can get it past here. Yeah, I think this is the big issue here. Okay, I think we can fix that. So let's undo that. I think this trace and this trace could be more efficient. Because I think if I can get you to sneak past that guy, I can get you to sneak past that guy. I think that will give me hopefully enough to get my power through there. All right, let's try again. So, okay. Yeah. Okay. Yeah. Ooh, that was a big mistake. Just the smallest amount. Okay. Bump that up just a bit. Let's make sure I screw up any of my other connections. 12 times a charm. Are you for real? Yeah, because that isolates. Well, I have an easy fix for that. So we're just going to do this. So that can go there. That can go there. I'm going to drop the ground plane. Here, maybe? Oh, can you not let me through there? Oh, come on. Alright, this is really pushing it, just because I don't want to make some simple changes there. Let me fix these guys. But I like goes there, which then lets me drop a ground via right there, which then lets me run this incredibly close to here. Cool, takes off that. Okay, bottom layer, ground. 5 snap. Okay. And layout. Come on, do it. Yeah. Whew. Probably not the best board in all of existence, but it works. Probably, maybe. Alright, so let's just clean up a little bit of our labeling here. Alright. And last but certainly not least, we'll go bottom silk. And we'll call this. LiPo. Oh no. Well, I think next time we're going to add a 3.3 volt conversion module to that. This will be P1.0. And there. By 15 meters, cool. And compare ours to theirs. I wonder how big theirs is. I don't know if it'll say. But we can find out. So 2.5 by 1.6, so 25 by 16. Ooh, this one bigger. 25 by 16. It's 5 millimeters longer. Alright, well, I think that is pretty good for a first run. So, I think that is the LiPo charging module. I think next time around we'll do one that has a 3.3 volt conversion for running ESP32s. But overall, we'll call that good enough for today. Yep. Thanks for watching.